Revenue is found by multiplying price by the number of units sold. For example, if you charged $2 per unit and sold 100 units, your revenue would be found by R equals the $2 you charge per unit times the 100 units you sold for a revenue of $200. Now in this problem, the price is given by this function, minus 1 over 50x plus 20,000, where x is the number of units demanded and sold. So the revenue then would be found, just like we did before, by multiplying the price, which is minus 1 over 50x plus 20,000, by the number of units sold, which is x. So multiplying those together, minus 1 over 50x plus 20,000 by x, what we would need to do is distribute this x over these two terms separated by that plus sign. And what we would wind up then with is a revenue of minus 1 over 50x squared plus 20,000x. Profit is found by subtracting cost from revenue. Now, we just found revenue to be R equal to minus 1 over 50x squared plus 20,000x. And we are given cost as C of x equal to 17,120x plus 20,000. So the profit then we would find by subtracting revenue minus cost. Now, since the cost function has two terms in it, we have to separate these things with parentheses because we would distribute that negative. Here's our revenue, minus 1 over 50x squared plus 20,000x. Here's our cost, 17,120x plus 20,000. And when we distribute the negative, that cost part becomes minus 17,120x minus 20,000. And when we combine these like terms, what we wind up with then is a profit function of minus 1 over 50x squared plus 2,880x minus 20,000. So our profit function then is, again, P of x equal to minus 1 over 50x squared plus 2880x minus 20,000. This profit function is quadratic. It has an x square, and therefore would be maximum at the vertex of the parabola that would be formed if we graph this, because this leading coefficient, the a part here, is negative, so it would open down, so it would have a maximum. One way we could find the vertex would just be by using this formula x equals minus b over 2a. This would give us the x coordinate of the vertex. And remember that x is the number of units. Okay, now, where do a and b come from? A and b come from the standard form for a quadratic function, which is f of x equals ax squared plus bx plus c. So matching that up then, we have a equal to minus 1 over 50, b equal to 2,880, and c equal to minus 20,000. All we need are b and a. So we substitute those into this formula, and we wind up with 72,000 units. So this would be the number of units that would maximize profit. Now the maximum profit would be what we would get if we substitute that 72,000 into the profit function. So everywhere there's an x in that profit function, we're going to put 72,000. So we have the profit for 72,000 units is minus 1 over 50 times 72,000 squared plus 2880 times 72,000 minus 20,000. And remember, using our order of operations then, what we would wind up with then is a maximum profit of 103,660,000. Now at the beginning of the problem, we were given that the price function is P equal to minus 1 over 50x plus 20,000, where x is the number of units. We found that profit is maximized at a production and sales level of 72,000 units. So substituting that into this price function, we find the price to maximize profit should be, and we substitute 72,000 in for x, and we wind up with a price of $18,560.